Okay, hi guys. So in this lecture, we'll be seeing a ratio variation method. So this is a part of the experimental methods for determining the order of reaction. So let's get started. So this is ratio variation method. So this is also called initial rate method. So the concentration of the reactants actually can increase or decrease in fixed ratio. This is the bottom line of this method. Concentration of reactant increase or decrease in fixed ratio. Okay, so suppose we have a reaction in which we have A plus B converting into C. So let's say the concentration of A and B and the rate of reaction is, when it's 0.1, it's 0.2, rate of reaction is 0.4, 0.2, the rate of reaction is 0.8, and when it is 0.2, 0.4, rate of reaction is 3.2. Okay, so let's assume that rate is equals to K into A to the power X and B to the power Y. So let the order with respect to A is X and let the order with respect to B as Y. With respect to A, and Y is the order with respect to B. Okay, so we have three equations in which we have first as 0.4, which be equal to K times 0.1 to the power X, 0.2 to the power Y. Then we have 0.8 equals to K times 0.2 to the power X and 0.2 to the power Y. Then we have 3.2, which is equals to K times 0.2 to the power X and 0.4 to the power Y. This forms three equations. We have three equations, three unknowns. We can derive the value of K, X and Y. So suppose we have 2 divided by 1, so we would get 2 would be equals to 2 to the power X. So this implies X would be 1. Now we have equation 3 divided by equation 2. So we would have 4 which be equal to point or rather 2 to the power Y. So this implies Y would be equals to 2. And this implies that order of reaction would be nothing but sum of partial orders or order with respect to reactants A and B. So that would be X plus Y. So 1 plus 2 is equals to 3 is the order of the reaction. Okay, so now we can also find the value of K. So we know that R equals to K, A to the power 1 and B to the power 2. So rate is, let's say we pick any of the equations. Let's pick first equation. So from first equation we can write that 0.4 is equals to K times 0.1 and 0.2 square. So this implies K would be 0.4 divided by 0.1 into 0.2 square. So this implies K would be equals to 100. Okay, and next is what would be the rate of reaction when A is 0.5 m and B is 0.2 m. So we have already know the value of K, which is 100, so just put it here. So R is equals to K, 0.5 to the power 1 and 0.2 to the power 2. So this is 100 times 0.5 into 0.04. So the rate can be calculated easily from this. So the rate would be 100 times 5 divided by 10 into 4 divided by 100, so it would be 2. Okay, so with this we come to the end of this lecture. In the next lecture we will be seeing one more method, which is Oswald's isolation method. So till then, good luck and goodbye.